Welcome back to Academic Matters at LaSalle University. I'm Brian Goldstein, Provost and Vice President for Academic Affairs. I'm joined now by Dr. Janet Fierson, Assistant Professor in the Department of Math and Computer Science. Welcome, Janet.
Thank you.
Can you describe your journey to LaSalle, what your academic training was, and how you ended up at the university?
Sure. So I grew up in New Rochelle, New York, about 2 hours north of here. And for as long as I can remember, I've loved math, so I knew I would do something involving math as a career. Then I went to Providence College for undergrad and majored in math there, and then went to Stony Brook University to get my PhD in applied math and statistics in the operations research track. And after that, I was at the U.S. Military Academy at West Point for 4 years in a teaching postdoc position. And then the year that I was coming out of there, LaSalle was hiring, and as Brother Ernest talked about, it was that community, the sense of community here that really got me and just pulled me in.
So I want to pick up on two things that you just mentioned. The first is that you knew from a very early age that you wanted to go into math, do something with math. And I understand that you used to wake up and ask your father for math problems. And so perhaps you can give advice, and maybe you do this with your own son now, how you can instill that love of learning in math in particular, which so many people have a phobia about at an early age.
So I think for me, I mean, I do remember I was about 5 or 6, and I knew it was too early for me to wake up yet, but I just couldn't wait to work on those problems. And I think my parents both really did a great job of just letting me explore things and then seeing what I got interested in. And one of those things, and I just got hooked on math, I guess. And I think, so my son's only 9 months old now, but I hope that I can do the same with letting him explore and figure out what he's really interested in. And I think one of the issues with some students coming into a math classroom is thinking that math is memorization and formulas, and that's all it is, or that's most of what it is. And I can see why, if that were what math was about, that I would hate it. So I think part of it is trying to help everybody to understand that that's not the real math. The real math is puzzles and problem solving, and just taking something that's messy out there in the real world and then trying to turn it into something that you can actually work with. So I have fun trying to change people's minds about math.
How then should we think about teaching math at a very early age? It seems like, my understanding is, children come to it, they enjoy it, and they like it less and less as they get older. And I think especially for girls and women who gravitate towards math and science very early on, and somehow that doesn't seem to translate into secondary and post-secondary education.
I think a big thing is just to keep the focus on that puzzle sort of aspect of it, the problem solving, as opposed to the more boring, I have to just memorize these things and fit this problem that I'm looking at now, match it up with something that I've done before, to really have a lot more. I think it's harder to create those sorts of problems because they are messier, but they are much more realistic and apply to the real world, and much more interesting to students, I think.
So I know your specific area of interest and research and focus is on applied math. So can you explain what applied math is? Because I think we all have this notion when we think of math, and how do you bring that aspect of the world and a puzzle into your classroom every day?
Sure. So during grad school, I was in the applied math and statistics program in the operations research track, and my research actually ended up being in computational applied math in the area of parallel computing, and specifically task mapping for parallel computing. So the general idea is that there's some big problem that needs to be worked on, maybe could be something like a problem in biology, and if it were to be run on a single processor, it might take weeks to figure things out. So it's being run on a parallel computer with thousands of processors instead, and the problem is divided up into tasks, into individual pieces, and those tasks get assigned to the processors of the network. So my research in grad school was in figuring out the best way, the optimal way to map the tasks to the processor. So the default mapping of task 1 to processor 1 might not be efficient. It might take a long time to run if the tasks that communicate a lot with each other are on processors that are far apart on the network. So that was the specific area of applied math that I first started really working on research-wise. And then I also moved into the area of graph theory, and that's another lots of applications there, where the idea of a graph is that you have a set of vertices, or you can look at it as points, and you have edges connecting those points. So the vertices might be things like cities, or they could be people, and then we get all sorts of networks like communication networks, transportation networks, social networks. So there are lots of different things looking at the centrality of different vertices, or it could be, say, people in a network. So I've been fortunate here to be able to bring those sorts of things into the classroom. I was able to design a graph theory course that hadn't been running previously before I was here. And that's somewhere where we can bring in, we do theory, we bring in proofs and make sure everybody understands why certain things are true. And then we can look at lots of applications of those networks. And then another course that I was fortunate to be able to design here was an honors course called the City of Mathematical Love instead of the City of Brotherly Love. So we were looking at applications of math in Philadelphia and other major cities.
So give me an example of how the City of Brotherly Love can become the City of Mathematical Love. Just one example that you're working on.
So one example might be we're looking at the transportation network, so SEPTA, looking at the stations as vertices of a graph, and then looking at the distances of the links, actual physical connections between stations. And we talked about it both in terms of the distances between them, the times between them, cost, how much it costs to travel from one place to another, and we can actually measure the efficiency of that network and compare it to the network of other cities, like Atlanta, for instance, was one that we looked at.
So I know that you are involved in scholarship on your own, that you are heavily invested in mentoring students. So talk a little bit about how you get students excited about research and scholarship, and how specifically you've been able to integrate them into your own work.
So I think here it's been great. It was something I knew I wanted to do, but of course you need to have interested students in order for that to happen. So I wanted to involve them in scholarship while they were here, and it's been great right from the beginning. There have been people who've been interested, and it's good having the problem, so to speak, of having more people than maybe you can work with at a time, but having people that will be able to join in at some point. And so I've been, I guess from the very beginning, I started asking in my classes at the beginning of the course in a survey, just asking some general questions to find out more about the students, and then also asking if they might be interested in grad school, interested in research. And anyone who says yes or maybe, I always try to find out a little bit more and see if there's something that we could work on together. And graph theory is great in that it's very easy to get right into a problem. You can start thinking about it, working on a problem right away without doing a lot of reading or having a lot of background, because a lot of those problems are like puzzles. And I've been able to work so far with 4 students in graph theory, and all 4 have actually been able to do significant work, and all 4 have gotten external funding to present their work at conferences, which has been really exciting. And it definitely sets them up well for grad school if that's in their plans, or even just for if they're going straight into a career, just working with those messy problems that aren't textbook, not problem number 5 in the textbook, where nobody in the world knows the answer to this. So I think that's one of the things that can kind of get them interested, is just knowing that no one else in the world is doing what you're doing right now, working on this particular problem.
So it seems like you've been blazing trails for a long time. So I'm interested to hear more about your experience at West Point, where I think you were the first civilian course director of an advanced math course. So talk about that experience and how you were able to use that experience and bring it into the classroom here.
So at West Point, this was a teaching postdoc position. It was the department there is a very large department, actually 70-something math faculty members. Mm-hmm. So the cadets there everyone takes 2 years of math regardless of major. So there was a lot of math teaching going on. And we actually even had a 6-week faculty development workshop prior to starting there, because there is such, since they are temporary positions, there is a lot of turnover each year in the faculty. And I was fortunate to be invited to teach in the advanced math program, which was for about the top 15 or so % of each incoming class. And then I was asked if I would be interested in being the course director, which meant that I would be involved in overseeing the selection process of determining which students would enter the program, and then actually overseeing the exams, the day-to-day operations of the course, and helping to run the team of instructors and manage the sections for the program. So that was definitely gave me a lot of experience that I wouldn't have had otherwise, and I'm able to bring it in, especially with the ability to work with other people and to get students thinking about the importance of working with each other also.
Dr. Fierson, thank you for being with us. This is Brian Goldstein from LaSalle University, Academic Matters.